So these are the different tool chains that we've identified that we believe will be of that we believe we can be of use to. Um,
Can I add
so the
one more
question,
to this?
what was that?
Can I add one more tool chain to this,
Absolutely,
which is Maven Central?
that is a fantastic one.
Probably put it between lines 18 and 19. Well, actually, let me go ahead. I'll go ahead in the background. It'll be easier. Um, it's interesting because Maven Central is kind of different than just Maven, the tool.
Yeah, in the same way that npm is different from the npm repository. So I think it shares that kind of relationship.
Yeah. The status is request made.
Okay.
Oh, cool. Do you want to give a quick description of Maven Central, just for those who are unfamiliar with the Java world?
So in Java land, Java source code is compiled into class files. Class files are then aggregated into jar files. Jar stands for Java Archive. They're basically souped up zip files that support signing and a few other things. In order to have an open source dependency in your project, you refer to the package, the group ID, the package ID, and the version. And those artifacts are stored publicly on Maven Central. And there are also some companies have internal repositories that will mirror a subset of Maven Central. But if we're able to start indexing what's in Maven Central, generate Gitoids for what's in Maven Central, we'll start to be able to do analytics on Java packages, which is actually the demo that I'm going to do in a few minutes. So being able to, there are 24 million jar files in Maven Central, and being able to index them will then lead to the ability to figure out the contents of any random jar file or web archive
Yeah.
WAR
So
file.
Nice.
yeah. So basically, if somebody goes and pulls things apart and reassembles them, which is not uncommon, you'll be able to trace the bits.
And that's a big issue with. Yeah, we're definitely excited with that. Okay, so with that, if we can go back to the main agenda, and with that, I think we jump into your topic.
Cool.
So go for it.
So I'm going to steal the screen, and so what I've done is I've generated an index of a subset, about 8,000 of the 24 million jar files on Maven Central. And I also built a tool that will generate Gitoids, just SHA-256 Gitoids, for both the file itself and then all of the contents and subcontents of the file. So it is, as Ed pointed out, it's pretty common for a bunch of different jar files, a bunch of different Java classes to be rolled into a single jar file. Those are sometimes called Uber jars or assemblies. So I've built a tool that will do analysis of both the jar files and the contents, and then look up the vulnerabilities in any discovered content. So I'm going to first just run it against log4j. And what we do is we take a look. We've generated a Gitoid for the main log4j. This happens to be one of the vulnerable ones. And we list all the vulnerabilities. So, we have a series of high CVSS high vulnerabilities. Any questions so far? So, we generate a Gitoid. We we use a lookup on the Gitoid, and the result is vulnerabilities. We can also run the same thing on a file that's not vulnerable. So in this case, Jakarta XML bind API, it was just, a jar file I pulled out, and this one has no vulnerabilities. So the next thing we're going to do is we're going to take a look at an Uber jar that contains a whole bunch of other libraries and custom code. So we've generated the Gitoid, and what you'll see is a series of fetches. So what winds up happening is we fetch based on the Gitoids, we fetch each of the bits of information. If the particular Gitoid is contained by another Gitoid or another file that has a Gitoid, the containing Gitoid is also pulled down so that we can do an analysis of what percentage of the files in the jar file are also are associated with a particular known package. So in the particular jar that we're analyzing, there's a 99% overlap between the contents of the jar and micro.json. And there's 96% overlap with WS3. And you kind of go down the list, and here are a whole bunch of different packages that are contained within the Uber jar, within the entire runnable jar file. And
so interesting. I have a question about the percentage overlap there. Is that basically saying, to take as an example, that that 99% of the files for that Gitoid are in upickle, or 97% are in upickle?
90 or let's pick upickle because it's actually a low number. So for upickle,
okay, yep.
There are 83% of the files that were indexed in upickle are also inside the jar file that we just analyzed. And so that the interesting thing is a lot of the class files overlap. In other words, you'll have you'll have the same class file across multiple versions of a jar file. So what you ultimately want to do is you want to say, but which one is it? And there are also some files that are excluded. For example, license files are often not copied over. Certain text files, certain manifest files are not copied over into an Uber jar. So it's very rare that you'll have 100% overlap. But ultimately what we care about is there something in here that has a vulnerability? And so let's go do an analysis of the same build, except we're using log4j 2.7 rather than log4j 2.22. So we're pulling, we're kind of going through the same process. And what we see is, we have roughly the same files, except we've discovered that we've got the contents of log4j 2.7. And we've got a 99.8% overlap. So we're pretty sure that it's log4j 2.7. And log4j 2.7 has a series of vulnerabilities in it. So what we've done is we've taken something for which we don't actually have a manifest for this Gitoid, for this thing that we built, but we can still pull it apart and look at the contents and say, by the way, this thing does have vulnerabilities in it. And so this is kind of, at least from my perspective, really demonstrating the power of OmniBOR, which is we can look at something for which we don't know exactly what's in there, and we can give a pretty good probabilistic estimate that either there's something bad or there's not something bad in there. So this is a demo, and I've posted in our Slack channel a bunch of URLs. All of the indices are public. So as I produce them, I publish them. And so basically if you have a SHA, an OmniBOR SHA-256 or Gidoid SHA-256 of something, you can look it up on the BombSage site and see whether it's been indexed or not. And as we index more stuff, we will have more content. Anyway, so that's it for the demo. Does anybody have questions, comments, concerns?
No, that's very, very cool.
I think this is one of the shortest and most exciting demos combined, which exciting does not surprise me, but the fact it was so short does.
Well,
um,
in particular, it really sort of demonstrates the power of being able to say, look, um, you've got problems in more places than you think you do.
yeah, and that's and this makes total sense as well. Like the fact that very often when somebody compiles a jar, like there's two class of thoughts with jars. The first one is only that jar only has a dependency that is explicitly stated, and the second class is to bundle things together as well, as in I have dependencies, I'm going to vendor those dependencies into my system. The first one tends to play really well with Maven Resolve, where Maven Resolve is like go get or similar. The second is where the dragons are, like of where people will be bit because they don't know what they don't know. And so the fact that this is able to give us a pointer that these are things at risk uh, is I think really good. And I think one of the things that we can possibly do in order to help with this is like eventually that issue with log4j was fixed. If we have 99.9% of the files look good and we look at a specific path, make sure there's only one path, not two paths to log4j. But if we see every version of log4j that we've identified in there happens to include the fixed version as identified by the Gidoid, then that's something that maybe we put into an audit log just for informational sake, but that's information we can suppress because chances are it's not vulnerable. So I think that there's
That feels like a
some real
job
interesting there.
for a vex statement.
Exactly.
If
now
only we could make this problem stop vexing us.
Yeah. Well,
Oh,
oh man.
Somebody had to.
yeah. So the other interesting thing about this approach is it lends itself to, you know, RPM files. It lends itself to debs. It lends itself to Docker layer image or image layers. All of these things are containers that contain other things for which you can determine whether or not there's a substantial overlap between what you're seeing and something that's vulnerable. The other thing, and Frederick, this is more to your point, there's some interesting analytics that can be done at a source code level. So what I haven't done yet with the system is I haven't done an index from the class file to the generated source or the Gidoid of the source that generated the class file. But if we take a look at how class files change or don't change based on a particular vulnerability, and the OSV stuff that's out of Google really has a lot of this rich information, we can start doing analysis of vulnerable source files and the class files that were generated from them. In other words, what source file was changed between a vulnerable version of log4j and the non-vulnerable version. Once we know that, we can then say, and what class files were generated between the vulnerable and non-vulnerable version. Once we know that, we can actually put flags on the individual class files rather than putting flags on the package version. So this technique lends itself, and the whole omnivore, having a tree, a directed acyclic graph of contents lends itself to a lot of really exciting analytics to start building a probabilistic model of how vulnerable or how risky a particular package or a particular set of packages that you have in production are. Is that sentence parse anyway?
So there's another thing that this will tie in very well with, which is so we're not seeing this in Java just yet, but if you look at npm, and I think PyPy and Rust are looking into this as well. To double check Rust on that, because they're still in the process of working out what they want to do. Last I checked, but one of the things that we're starting to see is for some of the repositories to include a build system that they control rather than being a developer controlled build system, or a SALSA compliant build system, where SALSA compliant basically meaning that think of like GitHub Actions or other similar systems that what they do is they produce a document that says a cryptographically signed document that says this is where this thing was, where it came from, as in like here's the Git repository, this is the actual commit that I used to build this thing, and this is the signed output that was produced, or at least include the output into the manifest, so that way that you can then validate it downstream and say that this package did indeed come from this build system, which was then linked to this exact commit. And so this has a couple of nice properties, one of which being that the developers, if they run through this, are not able to say, hey, here's the source code, and then they actually push something different. And so yeah, it allows for linkage of those two in a cryptographic way. But I think if since some of the systems are starting to produce some of this metadata, that might be something else that maybe we can look into slurping up in order to assist the automatic analysis of some of these types of vulnerabilities. And I wonder if the stuff that we're doing here for Java, if the non-Java specific parts, I suspect would work very similar for Python, or would work very similar for npm or similar. So just some thoughts.
Yeah, I 100% agree. And the thing that I've been struggling with in npm land is if you have something that's put together by a package manager, which will do stripping and a whole bunch of other stuff, how do you kind of go back and say, but this minified JavaScript file was actually from this source? Anyway, so anyway, I think there's a lot of fruit for discussion going forward. And as I build out more of the index, and as I figure out how to do this in a sane way, would love collaboration, and would love to make sure that we actually build usable tools, or at least usable prototype tools for people to say, should I put this into production? Or, as you said before, Frederick, should we log it as it goes into production so that we can determine what was on our cluster at any given point in time?
Yeah, this is something that I think is going to be very useful. So definitely really excited about this. Definitely count me in on improving the tooling on here.
Cool. Can you in Slack drop me your coordinates so I can follow up?
Sure, will do.
Thanks.
David, I had a question on the output that you shared in Slack yesterday. So it had the class file and then the Gitoid for it. What is the second field with the with some numbers. Like, I don't know if I should just, I'll just post a sample in the chat. Yeah. So I just posted it in the chat. So there is a class file and its gitoid. But what is the second? What does that refer to?
So let's see. Just trying to think. Actually, I have no idea what that number is.
Okay. I mean,
Sorry
that
about
is
that.
typically not in the, the as a part of the IAM, usually only have the dependency and its and the gitoid.
Oh, you know what? I think that number was just the number of bytes in the class file.
I see. Okay, the size of it maybe. Okay.
Yeah. So it was as part of computing the gitoid.
Okay.
So, it's but that was just, hey, I can walk a jar. That was back last week when I was just walking the jar files.
Okay.
Before I was doing any analysis. I think the thing to take a look at is being able to actually, hang on, let me just go post this in chat. Being able to take the URL and pull the richer information out of the URL. And one of the things that I'll definitely need help on is the format of the JSON file. I mean, I knocked some stuff together. I don't think it's production worthy, but it was demo worthy. And if we could start working, maybe have a separate work stream on what format should we publish metadata about a gitoid, I think that'd be really helpful. So we basically have the bidirectional index. In other words, what does this depend on and what depends on it, as well as vulnerability information, etc. Being able to start figuring out what that JSON looks like, I think will allow us to build common tooling around the format.
Yeah, and I think Yonki's BOR message tool also builds a JSON, something similar but not identical, of course. That's something to look up as well.
Okay, maybe what we'll do is, and I'll talk to Ed when he come next week. Maybe what we'll do is we'll start dedicating a percentage of the meeting to the JSON file, the JSON format, as well as some of the other stuff we've been working on, so that we normalize it between what I've come up with, what Jan Kui has come up with, and anything else that folks say, hey, we could use this, or this is a nice optional field.
Sure.
Okay, so who's going to share the?
Yeah, I'll share the agenda just a sec. Oops. Oops. Screen. Oops. Yeah. I think Andrew is not here. So we have to skip these two items.
Did we ever make the decision to change the meeting time, or is that still
That's still
work in
open.
progress?
I think that's still work in progress. We haven't decided on a time that would work yet, I don't think.
I think last week the bulk of the discussion was around whether we need both SHA-1 and SHA-256 hash types to be supported, or do we just do one, that is SHA-256? And I think that's where we didn't conclude that discussion either, but that's what we discussed. We spent a lot of time.
I do have a question with regards to this. So from what we just were demoed, it seems like the idea is that in order to identify whether something is vulnerable or not, we need to have a unique identity for every single possibly file that exists. Right, so that we can be like, okay, this class file, well, it has a vulnerability, so we can mark that and say, oh, that's vulnerable. So everybody, if you find this, I guess in this case, this identifier, then that means that you're probably vulnerable. And so really we don't have the option to have collisions in this world, if I'm wrong, right? Because if we do, then we're giving false positives of, hey, this thing is vulnerable, but maybe it's not, maybe it's something else. The likelihood of a SHA-1 being vulnerable is, or sorry, having a collision is very small, but I imagine the likelihood of a SHA-256 is still like much smaller or whatever. So just something to be thinking about with regards.
I think the SHA-1 issue is also a intentional collision issue. In other words, can you, for example, put enough chaff in a file to kind of overcome the wheat that points to a vulnerability? Or alternatively, can you put enough stuff that looks like it's vulnerable, but it's not really, into a file such that you effectively do a denial of service attack,
Yep.
which is, hey, you can't deploy this thing because it looks vulnerable, even though it's not really.
Right. Yep. And it wouldn't be necessarily an issue if we're trying to identify particular artifacts, specific getoids as being vulnerable. If you have this number, you are vulnerable, right? And so in turn, yeah, that's where it comes from, is like, if we can make, if somebody can easily make, or try and, like you said, fill in things that are bad into something, they can say that it's vulnerable. So
Well, think about a Docker layer. You have a whole bunch of files in a file system layer for Docker container. What is the probability that, if you think about, for example, an RPM or a deb file, if you think about an RPM or a deb file, they might contain 50 different files. You take that RPM or deb file and you extract it into a Docker image layer, and then you go and delete a bunch of the files. How do you then take the files that you've put on the file system and say, what package were they part of? And if you say, what package were they part of, let's say you only have 60% of the whole package, but it's 60% of a very vulnerable package. So the point of having the bidirectional index is you can take a bunch of individual files that in and of themselves might not have CVE or CVSS scores on them, but make a determination, a probabilistic determination, that those files are part of a package that is known to have a vulnerability. So that's the point of the bidirectional index.
mm-hmm. Got it. Yep. Yeah, you can identify things not just by, this allows us to do both, right? Not just identify by a specific file that you mark as vulnerable, but also as a conglomerate of things that might cause something to be vulnerable, I guess.
Yeah. So to Yanqui's point in chat about SHA-1 versus SHA-256, right now my index of 8,000 jars is about a gig uncompressed. If I did SHA-1 in addition to SHA-256, it would double the size. So the question is, what's the value of having the double size? In other words, using twice the storage to store the information. Yankui, do you have any thoughts on why you want both? If there's a storage cost and a computation cost to having both?
I mean, just in case of a clearing, right? We may want that. Also, I mean, different database, they may use different hash, right? I think we cannot exclude the case that people will use both. So I would think we just, for the tool, we just make it flexible to let user can configure. We can use the default, but make user can select, I mean, configure how they want to generate. That will be most, I think, desired for our tool, I think.
But what does SHA-1 give you that SHA-256 doesn't?
I mean, in case SHA-1 got cleared, right? It's almost much lower probability that SHA-256 will also get cleared, right? In that case, that's useful.
What do you mean get clear?
I mean, I think I mean, just my principle, you cannot exclude such case. So SHA-1 will in future may be deprecated, right? You want to convert to SHA-256 or SHA-5112, right? That kind of thing. So I think if you make your tool flexible, that will be more, than make your tool fixed at that. I mean, you can use the default configuration, that's fine, but I would just say, for me, I would like to make the tool configurable so that in some cases, although it's rare maybe, but user can still have the capability to select what hash they want to generate.
So
Okay.
I think when I last checked, Git has not yet transitioned to using SHA-256, but there is an option to use SHA-256 Gitoids if using an option. Until then, it's just that if you have the OmniBOR, if you have the IDs that are SHA-1 based, then if you're computing 256, then you don't have a way to look up and compare. So I think that was the reason why both SHA-1 and SHA-256 must be supported. That was the reasoning behind why it was added in spec that we will support both, because currently it's the transition hasn't happened to 256 yet. And if you say that if you're going to use 256, that means all the tools, like all the Gitoids we have in our database and generated by the tools should be only 256. So if we have a database of Gitoids that are SHA-1 based, and if we generate SHA-256 based, then it wouldn't be helpful. So as an option, I think we could generate both, but I certainly agree that having one SHA type definitely makes the difference in performance in terms of memory and space. Sorry, and time, yeah.
So that's also, yeah, for example, for the BOMS case, by default, we only generate SHA-1, but you have the option to either select SHA-256 only, or either have both, or nothing at all, like that. I mean, I think that will be the best. I don't want the tool to exclude the option for user to select what they want. It's just a default value versus what you can do.
Right. But I'm generating an index, I'm planning to generate an index of Maven Central. And if my index size, so hang on, let me just, so my, let me just calculate something. So if just a rough back of the napkin, the index that I'm going to generate with the SHA-256 is going to be about 3 terabytes.
Mm-hmm. I mean,
Should, do I need to generate another 3 terabytes of index for
no, you
SHA-1?
don't need unless user ask you to do, right? By default, you don't need, but you can provide option for user to
This is
specify.
not a user level thing. I'm building a public database.
Um,
So if I'm building a
yeah, I
public
mean,
database, then if
yeah,
I've got to build a 6 terabyte database versus a 3 terabyte database, that becomes non-trivial. If the database is replicated, then we're replicating 6 terabytes of data rather than 3 terabytes of data.
yeah.
Those numbers are starting to get big enough that they matter. And I'm trying to understand why we would want to generate a database that's twice as large. What's
No,
the benefit?
no, that's not what I'm saying. I'm saying you can give that option, but if you don't want to, it's fine. We don't force you. We don't mandate you to do that, right?
Well, the thing is that the database is the thing that people are going to be using to do lookups.
Yeah, I mean, if such a need, come up, they need SHA-256, then we will create that, right?
Now I'm
Because
defaulting to SHA-256 for the database I'm creating. So I'm asking why I would want to create a database of SHA-1. What's the benefit of having an extra 3 terabytes of data?
in our
When
case, probably there's no such need, but I don't think in future we have no such need either, right? So I just considering for future. For
right,
now,
but the
please.
demo that I just did required, for each analysis, it required about 10,000 lookups in the database. So, why would somebody want to do a lookup on SHA-1 versus SHA-256 when they're doing an analysis against the public database?
You're thinking, yeah, I don't know. For my case, for example, in Cisco, we do have both, okay? And I don't know exactly why people need both, but right now we're trying to create both.
Well, the
So
obvious use case would seem to be if you were trying to compare that to something you had in a git commit, which does use SHA-1, right? If you were trying to do that linkage all the way back, that would be the use case I would see.
Yeah.
So that would basically be the use case that we don't want to recompute something that gets already computed. So why bother? Is that kind of the argument because you've already got the gitoids in the .git directory?
Right. I would think that would be the argument. I'm not saying that's right or wrong, but I think that's where you end up at in that conversation. Yeah.
Okay.
Yeah, I think what Yonke is saying is if a build tool has an option to support more than one hash type, it's there. But we could just default to 256 and whatever the index, the database, whatever SHA type is there, I think that takes precedence over what the build tool would choose. So if you have the database for 256, then I think it is 256 today, tomorrow it could be something else. But then there might be an interim period of time where both SHA types would exist. So for such cases, I think the spec was just made extensible to support more than one. But for in practice, we could just choose to implement one algorithm that makes sense for the application.
yeah, that's right. That's what I'm saying. Yeah.
Cool.
Thanks.
Yeah, I think.
Yeah, I do think that the SHA-256 is better for a centralized database just because of this problem of if there ever, yeah, there's been proof, I guess, that you can create something that collides with SHA-1, which makes it bad choice. But so SHA-256 means that we can, at least for now, as far as we know, identify objects as uniquely as possible, I guess you might say, and not have to spend too much effort doing it. So yeah, I think that for a database, the SHA-256 default makes sense to me.
Yep, totally agree.
So I think we could change the spec not to mandate. Currently, it says that the ELF embedding and everything should count for both SHA-1 and SHA-256. And I think that mandate should be eliminated. And the support only for SHA-256 is compulsory now, and supporting more than one is optional based on the build tool's preference.
Yeah. The only benefit I see with having both, as you guys were saying, is that you can be even more sure that that they don't collide, right? Now we have twice the hashes to identify a single object, and the likelihood of those colliding is extremely low. So
Yeah, I don't see it as so much that as the fact that it's a convenience factor for people using Git to be able to make that correlation easily.
that's fair too. Yeah.
I mean, if you're using this and not trying to correlate it back to something in Git, which is using SHA-1, then using SHA-256 would certainly be preferable, right? If you're only comparing things outside of, you know, the Git repository, then I would see no reason to use SHA-1 for this.
Yeah.
So Ryan, you also bring up a really interesting point, and one of the attributes of Gitoids is they include the length of the file being looked at. And it'd be very interesting to carry the length of the file and the Gitoid as separate data structures, because even if you could create a SHA-1 collision, could you create a SHA-1 collision with exactly the same number of bytes?
Yeah, I thought about that too. Yeah.
Yeah.
That would be a simple fix for that additional, protection or whatever. Yeah.
Yeah, but the belt and suspenders of SHA-1 and SHA-256. In other words, if it having a collision with, being able to have the same file that has a collision for both, I think is, probabilistically impossible.
Yeah, I would agree.
Or, if somebody does it, they get the Nobel Prize for hacking.
Yeah. Yeah, agreed.
Okay. So I think the other items we don't have we don't have Andrew for discussing some of the other issues that he started. So I think anything else that needs to be discussed? So I'll just add a note that the conclusion is that SHA-256 should be supported, and supporting more than SHA-256 is optional, is optional to the build tool, and we need to make an edit to the spec to reflect that. Is that right?
Cool.
Okay. Yeah, I think we've reached the end of the agenda items that can be discussed today.
So there's one other item so I've been talking to Dan Applequist, who's now on the OpenSSF Technical Advisory Committee. And the question is, when does OmniBOR become, when does the spec and maybe some of our examples become ready for submission as, you know, to be an official project within the OpenSSF. And we don't have enough time to discuss that today, but want to leave everybody's brain, you know, working on that, so that next time we start talking about when do we move from where we are now to making this an official OpenSSF, or maybe Apache Foundation or some other entity official project. And there's you know, some additional value to having it be an official project, which is when something is official, government employees, and, you know, shepherded through a neutral party, government employees are more capable of engaging. Whereas right now, U.S. government employees are not. There are some restrictions to them engaging with the spec and with other things. So, you know, opening the project up to involvement with CISA or some of the other, you know, maybe NIST or others, I think also has value.
Mhm. Yeah, maybe we can take it up next week.
Cool.
All right, I think we can end the meeting a few minutes early today.
All right. Thanks, everybody.
Thank you.
Thanks.
Bye.